And we'll start with Steve. Can you give us sort of the 30,000-foot view? How did this get started? And I was going to say usually like what problem does it solve? But well, maybe we can kind of answer that. Well, tell us about it. Give us a 30,000-foot view.
Sure. The project actually began about 1995, believe it or not. At the time, I was teaching as a civil engineering faculty member at the U.S. Military Academy at West Point. And the Academy had recently decided to have a major celebration of its bicentennial, the 200th anniversary of its founding, which was going to happen in 2002. And the senior leadership of the Academy, in conjunction with that process, that planning process, decided that they wanted to run a national engineering competition for kids because West Point is the nation's first school of engineering. So they wanted to call attention to the engineering heritage of the Academy at its bicentennial celebration. At that time, as I said, I was teaching civil engineering, and my boss had just seen a student activity that we ran in the department. And this is exactly the sort of thing that Aaron was just talking about, a school-based project where, in our case, undergraduate students engaged in a little informal competition where they designed bridges and they built them up out of balsa wood, and then they tested them to failure, and they had a competition to see who could design the most efficient bridge model. And my boss was just enamored of this contest. And he said, that's what we need to do for this bicentennial celebration. We need to engage middle school and high school kids across the nation in this bridge building activity, and it'll be educational, and it'll be fun, and it'll call attention to West Point. And of course, I had just arrived as a senior faculty member at the Academy, and I immediately became the officer in charge of the project with this responsibility to somehow design a national competition for kids that was going to be scalable and implementable at some sort of reasonable cost. It didn't take long to figure out that supplying all the youth of the nation with balsa wood and having them all building bridges and doing this on a national scale was just absolutely logistically impossible. You know, if you think about the implications, in order to test a balsa bridge, you have to break it, but you can't do the entire nation's bridges at one time and determine a winner. So you'd have to do this at local level at the schools, and then you'd have to do it regionally, and then you'd have to do it at the national level. And at each level, you break the bridges, so the kids would have to build new bridges at each stage, and you'd need thousands and thousands of volunteers to be able to run the contest at local level. And it was very clear that this concept, as attractive as it might seem, was really just impossible to pull off. But of course, I couldn't go back to the boss and say, we can't do this. And so as an alternative, we started kicking around the idea of doing it virtually, doing it over the internet with a simulation instead of physical model bridges. And that's where the concept was born. In that year, I started working on the first edition of the software project, the software product, which at the time was called the West Point Bridge Designer. And I wrote the initial source code for a standalone Windows application. It was written in Visual Basic, believe it or not. Whoa. But I'm an engineer, not a programmer, so I was working in the only medium that I was actually capable of working in. By 1998, I had a fully functional version of that software up and running that we could then distribute in preparation for using it as the vehicle for the competition in 2002. But that was really where we reached the limit of my programming skills. And that's where Gene got involved as the legitimate computer scientist in the family. And Gene's major irreplaceable contribution during those early years of the project was to develop the web-based information infrastructure that would be capable of receiving designs that were created by this standalone Windows application and judging them and saving them in a database and scoring them and posting the results in real time on an electronic scoreboard so that we could actually implement the contest on a national level. And I'll let Gene talk to you about the technical details of how he pulled that off. But ultimately then the genesis of the project was an attempt to do virtually what we could not possibly have done physically, and at the same time to provide a really valuable educational experience for the kids participating in the contest. Because ultimately, we can create, using the simulation software, an engineering design experience that is far more authentic, much closer to the way real engineers design real structures than you can possibly do with balsa wood and physical models.